June 7, 1942. The waters northeast of Midway Atoll. Lieutenant Commander Eugene Lindsay's torpedo squadron was already doomed, and every man in VT-6 knew it. 14 Douglas TBD Devastator torpedo bombers, obsolete the day they were built, lumbering toward the Japanese carrier fleet at barely 110 miles per hour. No fighter escort. Japanese Zeros swarming like angry hornets. The mathematics of the situation were brutally simple. Preparing and narrating this type of story took us long efforts and hard work. So if you are enjoying the story, please consider subscribing to our channel. But 300 miles to the southeast, aboard the USS Hornet, a different kind of torpedo bomber was preparing for launch. The Grumman TBF Avenger, brand new, untested in combat, and carrying something that would fundamentally challenge every assumption Japanese naval commanders held about what an American torpedo bomber could do. The Japanese had been fighting American torpedo bombers for 6 months. They knew these aircraft intimately, slow, fragile, predictable. The TBD Devastator maxed out at about 115 miles per hour with a torpedo slung underneath. It required a long, straight approach run to drop its weapon. It was defended by a single .30 caliber machine gun in the rear cockpit. Japanese fighter pilots had learned to simply position themselves behind these lumbering targets and shoot them down at leisure. At Midway, 41 American torpedo bombers would attack the Japanese carriers. 35 would be shot down, an 85% casualty rate, but buried in those statistics was something Japanese intelligence officers would spend months trying to understand. 6 of those attacking aircraft were TBF Avengers from VT-8 detachment. They flew faster than any torpedo bomber the Japanese had encountered. They carried heavier defensive armament, and most significantly, they delivered their weapons from altitudes and speeds that conventional torpedo bomber doctrine said were impossible. 5 of those 6 Avengers were shot down at Midway. But the one that survived brought back evidence that would reshape American naval aviation strategy and shatter Japanese assumptions about what torpedo bombers could achieve. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. The Japanese combined fleet had built its defensive doctrine around a specific understanding of torpedo bomber capabilities. This wasn't guesswork. It was based on 4 years of observing American and British naval aviation during the late 1930s and 6 months of combat experience since Pearl Harbor. Every navy in the world understood certain fundamental limitations about aerial torpedo attacks. First, the torpedo itself imposed strict requirements. The Mark 13 aerial torpedo that Americans used weighed approximately 2,000 pounds. It was a massive weapon, nearly 14 feet long, 22 inches in diameter, packed with 600 pounds of Torpex explosive. When you hung this weapon under an aircraft's belly, you fundamentally changed that aircraft's performance characteristics. The added weight and drag meant reduced speed, reduced climb rate, reduced maneuverability. Second, the attack profile was predictable. To successfully drop a torpedo, an aircraft needed to approach its target at low altitude, typically between 50 and 150 feet above the water. The aircraft needed to be flying straight and level during the final approach. Speed had to be carefully controlled, usually between 100 and 120 miles per hour for the TBD Devastator. Drop the torpedo too fast, and it would break apart on water impact. Drop it from too high, and it would dive too deep before leveling out. Drop it while maneuvering, and it would tumble off course. This meant torpedo bombers were incredibly vulnerable during their attack runs. For 30 to 60 seconds, they flew predictable paths at low altitude and moderate speed. Japanese anti-aircraft gunners and Zero fighters had ample time to track, aim, and destroy these aircraft. The kill rates proved it. At the Battle of the Coral Sea in May 1942, American torpedo bombers suffered 30% losses. At Midway, 1 month later, the losses climbed to 85%. Japanese carrier doctrine adapted to exploit these vulnerabilities. Zeros maintained combat air patrol at multiple altitudes, with dedicated sections assigned to intercept torpedo bombers specifically. These fighters would dive on the attacking aircraft during their final approach runs when the American planes were most vulnerable and least maneuverable. Anti-aircraft batteries aboard Japanese carriers and escorts were positioned to create overlapping fields of fire at the exact altitudes torpedo bombers needed to use. The doctrine worked. Through the first 6 months of the Pacific War, Japanese carriers had proven nearly invulnerable to American torpedo attacks. At Coral Sea, despite heavy American airstrikes, only one torpedo hit was achieved against the carrier Shokaku. At Midway, despite wave after wave of desperate American attacks, not a single torpedo found its mark. The Japanese had mathematically solved the torpedo bomber problem, or so they believed. The Grumman TBF Avenger existed because the United States Navy understood their existing torpedo bombers were inadequate. The Douglas TBD Devastator had entered service in 1937 as a revolutionary aircraft, the Navy's first all-metal monoplane torpedo bomber. But by 1940, it was obsolete. The Navy issued a request in 1940 for a new torpedo bomber with dramatically improved performance specifications. They wanted speed, at least 250 miles per hour maximum speed without a torpedo load. They wanted range, enough fuel capacity for a combat radius of at least 200 miles. They wanted defensive armament, multiple machine guns to fight off attacking fighters. They wanted payload flexibility, the ability to carry torpedoes, bombs, or depth charges interchangeably. And critically, they wanted ruggedness, an aircraft that could absorb battle damage and still bring its crew home. Grumman Aircraft Engineering Corporation responded with a design that was radical in its approach. Rather than simply making a bigger, more powerful version of existing torpedo bombers, Grumman's engineers fundamentally reconsidered what a torpedo bomber should be. Chief designer Bob Hall and his team made several revolutionary decisions. First, they designed the aircraft around the Wright R2600 twin cyclone engine, a 14-cylinder radial producing 1,700 horsepower. This was nearly double the power of the engine in the TBD Devastator. The massive power plant would give the Avenger speed and climb performance unprecedented in a torpedo bomber. Second, they incorporated an internal weapons bay. Every existing torpedo bomber carried its weapon externally, slung under the fuselage. This created enormous drag and made the aircraft slower and less maneuverable. Grumman designed the Avenger with a fuselage large enough to enclose the torpedo completely within the aircraft. A hydraulically operated bay door would open only during the attack run. This single innovation would allow the Avenger to fly significantly faster than conventional torpedo bombers, even while carrying a full weapon load. Third, they built the aircraft with strength in mind. The Avenger's structure used heavy-gauge aluminum alloys and robust load-bearing members. The design incorporated armor protection for the crew, self-sealing fuel tanks to prevent catastrophic fires, and redundant control systems. The aircraft was engineered to be shot at and to survive. The prototype XTBF-1, the Torpedoes port, first flew on August 1, 1941, from Grumman's facility at Bethpage, New York. Test pilot Robert Hall put the aircraft through its paces and immediately recognized something exceptional. With the weapons bay empty, the Avenger achieved a maximum speed of 278 miles per hour at 12,000 feet. Even with a Mark 13 torpedo loaded internally, the aircraft could maintain speeds approaching 275 miles per hour in level flight. This was revolutionary. The TBD Devastator, with its torpedo slung externally, managed barely 115 miles per hour. The Avenger, with its torpedo enclosed internally, was more than twice as fast. The speed differential wasn't just impressive on paper, it represented a fundamental shift in torpedo bomber tactics and survivability. Production TBF-1 Avengers began reaching operational squadrons in early 1942. The first unit to receive the aircraft was Torpedo Squadron 8, VT-8, commanded by Lieutenant Commander John Waldron. But there was a problem. The squadron was already deployed aboard USS Hornet, preparing for operations that would become the Battle of Midway. There wasn't time to equip the entire squadron with the new aircraft. Instead, a detachment of 6 TBF Avengers was formed under the command of Lieutenant Langdon Feebeling. These 6 aircraft would operate from Midway Atoll itself, rather than from the carrier. They would be the TBF Avengers' combat debut. The aircraft the Japanese encountered that day represented capabilities that contradicted everything their intelligence had told them about American torpedo bombers. The Avengers' specifications told part of the story. Wingspan of 54 feet 2 inches, length of 40 feet overall, height of 16 feet 5 inches, empty weight of 10,555 pounds, maximum takeoff weight of 17,893 pounds. That maximum weight figure was significant. It meant the Avenger could carry its 2,000-pound Mark 13 torpedo, plus full fuel load, plus ammunition for all its defensive weapons, and still operate effectively. The power-to-weight ratio was exceptional. The Wright R26008 engine produced 1,700 horsepower, driving a 3-bladed Hamilton Standard constant-speed propeller. This gave the loaded Avenger a maximum speed of 271 miles per hour at 12,000 feet and a cruising speed of 145 miles per hour. The aircraft could climb to 10,000 feet in approximately 11 minutes, even when fully loaded. Combat radius was approximately 260 miles with a full torpedo load, or up to 480 miles carrying bombs instead of torpedoes. Maximum range with extra fuel tanks reached over 1,000 miles. These numbers meant the Avenger could reach targets, attack effectively, and still have fuel reserves to return to its carrier or base. Defensive armament was formidable. The Avenger carried 150 caliber Browning M2 machine gun mounted in the upper cowling, firing forward through the propeller arc. The gun was synchronized to avoid hitting the propeller blades and carried 300 rounds of ammunition. This forward-firing weapon gave the pilot offensive capability against ground targets or air targets of opportunity. The dorsal turret housed another 50 caliber Browning, operated by the turret gunner positioned behind the pilot. This electrically powered turret could traverse 360 degrees and elevate from horizontal to vertical, giving coverage against attacking fighters from almost any angle. The gun carried 400 rounds of ammunition. A ventral position beneath the rear fuselage mounted a single 30 caliber Browning machine gun, operated by the radio man positioned in the lower fuselage compartment. This weapon covered the aircraft's so vulnerable underside and carried 500 rounds. The 3-gun armament represented 3 to 4 times the defensive firepower of the TBD Devastator. The internal weapons bay measured 58 inches long and could accommodate 1 Mark 13 torpedo, 1 2,000-pound bomb, 4 500-pound bombs, or specialized weapons including mines and depth charges. The hydraulic bay doors opened in approximately 3 seconds, allowing rapid weapon release. The internal carriage meant the Avenger maintained its streamlined shape and optimal aerodynamics throughout most of its mission, only experiencing increased drag during the brief seconds when the bay doors were open. What Japanese observers couldn't see but intelligence officers would later discover was the aircraft's construction quality. Grumman had built the Avenger using manufacturing techniques that prioritized strength and repairability. The fuselage and wings used a combination of heavy structural frames and stressed skin construction. Critical areas incorporated armor plating to protect the crew and vital systems. The fuel system used self-sealing tanks located in the wing center section. These tanks incorporated multiple layers of rubber compounds that would swell when punctured by bullets or shrapnel, automatically sealing holes and preventing fuel loss. The system wasn't perfect, but it dramatically improved survival rates when aircraft took fire. Control systems incorporated redundancy. Primary flight controls used cables running through protected channels. If cables were severed by battle damage, the aircraft remained partially controllable through trim tabs. The tail surfaces were built exceptionally strong, with heavy spars and multiple ribs, allowing the aircraft to maintain control, even with significant damage to the empennage. The cockpit layout reflected lessons learned from early war combat. The pilot sat high in the fuselage with excellent visibility. Instruments were logically arranged using a standardized panel layout that would become common across American naval aircraft. Controls were positioned for easy access during high-stress combat situations. The canopy incorporated armor glass panels that provided protection without significantly restricting visibility. Behind the pilot, the turret gunner occupied a position that gave him commanding views in all directions except directly forward. The turret itself was manufactured by Grumman using electric motors that could traverse and elevate the gun rapidly. The gunner had armor protection behind and below his position. The radioman occupied the lower fuselage compartment, operating radio equipment, manning the ventral gun, and serving as a second set of eyes, watching for threats. This three-man crew represented another innovation. The TBD Devastator had carried only 2 crew members. The additional radioman in the Avenger distributed workload provided redundancy if crew members were wounded, and gave the aircraft better situational awareness. In the desperate environment of Pacific carrier warfare, that extra crew member often meant the difference between an aircraft making it home or being lost. Japanese intelligence had collected some information about the TBF Avenger before Midway. American newspapers had published articles about the new torpedo bomber entering service. Technical publications had included basic specifications, but raw numbers on paper couldn't convey what it meant when these aircraft actually appeared in combat. June 4, 1942. Approximately 700 hours. 6 TBF Avengers from VT-8 detachment took off from Midway Atoll's eastern island airfield. Lieutenant Fieberling led the formation. Their mission was to locate and attack the Japanese carrier force that reconnaissance aircraft had spotted approaching from the northwest. Each Avenger carried a Mark 13 torpedo in its internal bay. The weather was clear with excellent visibility. At approximately 7:50 hours, the Avengers sighted the Japanese carrier force. 4 carriers, Akagi, Kaga, Hiryu, and Soryu, screened by battleships, cruisers, and destroyers. The carriers were conducting flight operations, recovering aircraft from the first strike on Midway, and preparing to launch a second wave. Fieberling led his 6 aircraft into attack formation. The plan was standard torpedo bomber doctrine: approach at low altitude, release weapons at optimal range, break away before enemy defenses could concentrate. What happened next would become legendary in American naval aviation, though the full story would only emerge from Japanese records examined after the war. The Avengers descended to attack altitude, approximately 150 feet above the water. But unlike the TBD Devastators that would attack later that morning at agonizingly slow speeds, the Avengers maintained velocities approaching 200 miles per hour during their approach runs. This speed shocked the Japanese defenders. Zeros diving to intercept found their targets moving much faster than expected. The closure rates were wrong. The deflection angles were different. Fighter pilots who had perfected techniques for shooting down slow-moving Devastators suddenly faced aircraft that were there and gone before optimal firing solutions could be established. The Avengers' defensive armament added to Japanese difficulties. The dorsal turret gunners engaged, attacking Zeros aggressively. 50 caliber tracers arced through the sky as turret gunners tracked enemy fighters. While these defensive guns rarely shot down attacking aircraft, they forced the Zeros to maneuver, disrupting their attack runs and degrading their accuracy. The ventral guns covered the aircraft's blind spots, creating fields of fire that made close stern approaches dangerous for Japanese fighters. 5 of the 6 Avengers were shot down. Lieutenant Fieberling's aircraft was hit repeatedly and crashed into the Sea. 4 other Avengers suffered similar fates, overwhelmed by the concentration of defending fighters, but Ensign Albert Ernest's aircraft survived despite taking devastating damage. His turret gunner, Radioman 3rd Class J. Manning, was killed. His radioman, Seaman 1st Class Harry Ferrier, was wounded. The aircraft's hydraulic system was destroyed. The elevator controls were damaged. The bomb bay doors were jammed partially open. Ernest nursed the crippled Avenger back to Midway, where he executed a wheels-up landing on the reef runway. The aircraft was destroyed on landing, but Ernest and the wounded Ferrier survived. When maintenance personnel examined the wreckage, they counted over 70 bullet and shell hits. The aircraft had absorbed punishment that would have destroyed a TBD Devastator multiple times over. Japanese after-action reports from Midway noted the appearance of a new American torpedo bomber type. Intelligence officers compiled details from pilot debriefings. The new aircraft was significantly faster than previous American torpedo bombers. It appeared more heavily armed and more robustly constructed. It seemed capable of operating at higher speeds during attack runs than doctrine suggested was possible for torpedo delivery. These observations were troubling but not immediately alarming. The Americans had introduced a better torpedo bomber. That was expected. Technology progressed. What Japanese commanders didn't yet understand was that the TBF Avenger represented not just incremental improvement, but a fundamental shift in torpedo bomber design philosophy and capability. The evidence would accumulate through the summer and fall of 1942 as more Avenger squadrons entered combat. At the Battle of the Eastern Solomons in August, Avengers from USS Saratoga and USS Enterprise attacked the Japanese carrier Ryujo. The attacks were more successful than Midway. The Avengers' speed and ruggedness allowed them to press home attacks, despite heavy defenses. Ryujo was hit by multiple bombs and torpedoes and sank. At the Battle of the Santa Cruz Islands in October, Avengers again demonstrated capabilities that Japanese defenders found difficult to counter. Aircraft approaching at high speeds forced defending Zeros to adjust tactics. The Avengers' ability to absorb damage meant that even aircraft hit multiple times often completed their attacks before going down. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late 1942, Japanese naval intelligence had accumulated enough information to conduct detailed analysis of the TBF Avenger threat. What they discovered challenged fundamental assumptions about torpedo bomber design and capabilities. The analysis centered on several key factors that seemed to violate established doctrine. First, the speed issue. Japanese intelligence confirmed that TBF Avengers could approach targets at speeds exceeding 250 miles per hour and still successfully drop torpedoes. This contradicted everything naval aviators understood about torpedo delivery. The Mark 13 torpedo was known to be fragile. Drop it too fast and the weapon would break apart on water impact or malfunction. Japanese torpedo bombers, the Nakajima B-5N Kate, approached at carefully controlled speeds between 130 and 160 miles per hour during final attack runs. This speed range had been established through extensive testing. Drop faster, and torpedo reliability suffered dramatically. The Americans appeared to be dropping torpedoes at speeds nearly 100 miles per hour faster than Japanese doctrine allowed. The explanation, when Japanese engineers finally understood it, revealed sophisticated American weapons development. The Mark 13 torpedo had been substantially redesigned between 1940 and 1942. Early versions were indeed fragile and unreliable. But American ordnance engineers at the Naval Torpedo Station in Newport, Rhode Island, had systematically addressed every failure mode. They strengthened the torpedo's tail structure to withstand higher impact forces. They redesigned the nose section to reduce the likelihood of damage during water entry. They modified the depth control mechanism to handle more violent entries. They added wooden stabilizing shrouds, breakaway components that would cushion initial water impact and then detach, allowing the torpedo to run normally. These modifications allowed the Mark 13 to be dropped from altitudes up to 400 feet and speeds up to 300 miles per hour. The TBF Avenger could exploit this improved weapon performance because of its internal bomb bay. With the torpedo enclosed inside the fuselage, the aircraft maintained streamlined flight characteristics right up to the moment of weapon release. The pilot could keep the aircraft at high speed during the approach run, open the bay doors, release the torpedo, close the doors, and immediately begin evasive maneuvers. The entire sequence from bay doors opening to weapon away to doors closing took less than 5 seconds. Compare this to the external carriage used by Japanese Kate torpedo bombers or American Devastators. Those aircraft carried their torpedoes in exposed racks beneath the fuselage. The exposed weapon created constant drag throughout the mission. The aircraft had to slow down significantly before weapon release because the torpedo's exposure to airflow at high speeds created instability. After release, the aircraft still had the empty torpedo rack creating drag, limiting acceleration and maneuverability during the critical escape phase. Japanese analysts calculated that the TBF Avenger's internal weapons bay provided approximately a 30% speed advantage over externally carried weapons during combat operations. In practical terms, this meant an Avenger could approach a target faster, giving defending fighters less time to intercept. It could release its weapon and immediately accelerate to maximum speed for escape, and it could maintain higher speeds throughout the return flight to its carrier, reducing exposure time to enemy combat air patrols. The second factor that troubled Japanese analysis was the Avenger's apparent ability to deliver weapons accurately despite its high attack speed. Torpedo bombing was a precision art. The pilot needed to establish the correct altitude, speed, and approach angle. Too high or too low, too fast or too slow, wrong angle of attack, any of these variables being incorrect, would result in a miss or a malfunctioning torpedo. American pilots flying TBF Avengers seemed able to maintain accuracy even while conducting attack runs at speeds that should have made precision impossible. Japanese intelligence officers interviewed captured American aircrew when opportunities arose. They examined recovered TBF Avengers from crash sites. What they discovered was a sophisticated approach to pilot training and aircraft systems integration. The TBF Avenger's cockpit instruments were specifically designed for torpedo attack profiles. The pilot had a dedicated altimeter with clear markings for optimal torpedo release altitudes, an airspeed indicator with prominent markings showing the acceptable speed range for weapon delivery, a specialized bomb sight, the Mark 13 torpedo director, that calculated release point based on target speed, range, and torpedo characteristics. More significantly, American pilot training emphasized what became known as the high-speed torpedo approach. Pilots practiced maintaining high speeds until the final moments before weapon release, then smoothly reducing power and adjusting attitude to meet torpedo release parameters. This technique required exceptional skill and extensive practice, but it maximized survivability while maintaining attack effectiveness. Japanese Kate pilots used a different technique. They established their attack parameters early, flying the entire final approach at constant altitude and speed. This made the attack more consistent and easier to execute, but it also made the aircraft predictable and vulnerable. The difference in philosophy reflected broader contrasts between Japanese and American training approaches. The third analytical concern was the TBF Avenger's survivability. Japanese combat reports consistently noted that Avengers absorbed more battle damage than other American torpedo bombers before going down. Aircraft that should have been destroyed by hits that would have crippled a Devastator somehow made it back to their carriers. The explanation involved multiple engineering decisions that Grumman had made during the design process. The airframe structure was simply stronger than comparable aircraft. Grumman engineers had designed the Avenger to withstand 9 G-forces positive and 6 G-forces negative. This structural strength meant the aircraft could absorb battle damage to non-critical areas and maintain structural integrity. The self-sealing fuel tanks worked more effectively than Japanese equivalents. American chemical companies had developed rubber compounds that swelled rapidly when exposed to fuel, sealing bullet holes within seconds. Japanese self-sealing tanks, when they existed at all, used less sophisticated compounds that sealed more slowly and less reliably. An Avenger could take multiple hits to its fuel system and usually return to base. A Kate with similar damage would often catch fire or run out of fuel before reaching safety. The 3-man crew provided redundancy that 2-man crews lacked. If the pilot was wounded, the turret gunner could sometimes provide guidance and assistance. If the radioman was incapacitated, the turret gunner could operate the radio. Multiple crew members meant multiple sets of eyes watching for threats, multiple hands to manage damage control, Multiple chances that someone would survive to report what happened if the aircraft was lost. Armor protection was strategically placed throughout the aircraft. The pilot had armor plating behind his seat and beneath his position. The turret gunner had armor protection on several sides. Critical components like the engine, oil tank, and hydraulic lines had armor shielding. This armor didn't make the aircraft invulnerable, but it increased the likelihood that hits to protected areas would be survivable rather than catastrophic. Japanese analysts produced detailed reports comparing the TBF Avenger to their own Nakajima B-5N Kate torpedo bomber. The comparison was sobering. The Kate had entered service in 1937 and by 1942 was clearly obsolescent. Its maximum speed of 235 miles per hour without a torpedo load dropped to approximately 180 miles per hour with an externally mounted Type 91 torpedo. The Kate carried defensive armament of one 7.7mm machine gun in the rear cockpit. This single light machine gun was largely ineffective against American fighters. The aircraft had minimal armor protection. It lacked self-sealing fuel tanks in most variants. The crew consisted of pilot, navigator bombardier, and radio operator gunner, but the aircraft systems were not designed for easy crew redundancy. The Kate's range was excellent, approximately 1,000 miles, and its torpedo delivery accuracy was good when pilots could conduct unmolested attacks. But survivability in defended airspace was poor. When American fighters intercepted Kate formations, the loss rates were devastating. At the Battle of Midway, Kate torpedo bombers attacking the American carriers suffered approximately 60% casualties. Japanese aviation industry in 1942 was aware of the Kate's shortcomings. Design work was underway on a replacement, which would eventually become the Nakajima B-6N Tenzan. But this new aircraft wouldn't enter service until 1943, and even then it would represent only incremental improvement over the Kate, rather than the revolutionary leap the TBF Avenger represented over the TBD Devastator. The fundamental problem was industrial capacity and design philosophy. Grumman had been able to design the Avenger around a 1,700 horsepower engine because American industry could produce such engines in quantity with consistent quality. Japanese industry struggled to produce the 1,400 horsepower engines for the B-6N Tenzan in adequate numbers, and quality control issues plagued production. Grumman had incorporated an internal weapons bay because American manufacturing techniques allowed construction of large, complex fuselage structures with adequate strength. Japanese manufacturing, while sophisticated, relied more heavily on built-up structures assembled from smaller components. Creating an internal weapons bay large enough for a torpedo would have required manufacturing approaches. Japanese factories were not equipped to implement at scale. The TBF Avenger's sophisticated systems, electrical turret, hydraulic bomb bay doors, advanced instruments, required electrical and hydraulic components manufactured to tight tolerances. American suppliers like Hamilton Standard, General Electric, and Sperry Gyroscope could provide these components in quantity. Japanese suppliers existed, but production capacity was limited, and quality was less consistent. By early 1943, Japanese naval aviation commanders understood they faced a significant capability gap in torpedo bomber effectiveness. American carrier task forces were equipped with aircraft that could attack faster, from greater distances, with better accuracy, and with higher survival rates than Japanese equivalents. This gap contributed to a broader pattern, where American aviation technology was advancing more rapidly than Japanese industry could match. The Battle of the Philippine Sea in June 1944 demonstrated the consequences with brutal clarity. American carrier task forces included 7 fleet carriers and 8 light carriers, embarking over 900 aircraft. Approximately 1/4 of those aircraft were TBF Avengers. When Japanese carrier aircraft attacked the American fleet, they faced not just superior fighters and anti-aircraft defenses, but also the challenge that American torpedo bombers could respond with effective counterattacks. The battle became known as the Great Marianas Turkey Shoot. American fighters and anti-aircraft fire destroyed approximately 600 Japanese aircraft over 2 days. Japanese attacks achieved minimal results. American counterstrikes devastated the Japanese carrier force. TBF Avengers played significant roles in these strikes, attacking Japanese carriers with both torpedoes and bombs. The Avengers' versatility had emerged as one of its most valuable characteristics. While designed as a torpedo bomber, the aircraft proved equally effective in other roles. The internal weapons bay could carry 4 500-pound bombs for strikes against surface ships, shore installations, or ground targets. This loadout made the Avenger an effective dive bomber, using tactics similar to dedicated dive bomber aircraft, but with the advantage of greater payload capacity and longer range. As the war progressed into 1944 and 1945, American carrier air groups increasingly used their Avengers in mixed strike packages. Some aircraft would carry torpedoes, others bombs, creating layered attacks that were difficult for defenders to counter. A Japanese carrier might face high-altitude bombers, low-altitude torpedo planes, and medium-altitude glide bombers all attacking simultaneously from different vectors. The Avenger also proved effective in anti-submarine warfare. Equipped with radar, sonobuoys, and depth charges or acoustic homing torpedoes, TBF Avengers hunted Japanese submarines throughout the Pacific. The aircraft's long range and endurance made it ideal for maritime patrol. Its internal weapons bay could carry specialized anti-submarine weapons. Avenger squadrons, operating from escort carriers, provided convoy protection and conducted offensive anti-submarine patrols. Night operations became another Avenger specialty. Equipped with radar and flown by specially trained crews, TBF Avengers conducted night strikes against Japanese shipping and installations. The aircraft's stability and robust construction made it suitable for night carrier operations, which were exceptionally demanding and dangerous. Japanese naval aviation never developed equivalent night strike capabilities, giving American forces a significant advantage in round-the-clock operations. By 1945, the TBF Avenger had become the standard torpedo bomber for the United States Navy and Marine Corps. Over 9,800 examples were produced during the war. Grumman manufactured approximately 7,700 TBF models, while Eastern Aircraft Division of General Motors produced approximately 2,100 TBM models under license. The similar designations reflected essentially identical aircraft, with only minor differences in equipment and subcontractors. Japanese forces encountered Avengers throughout the Pacific theater. During the Philippines campaign in late 1944, Avengers struck Japanese shipping, airfields, and ground positions. At Iwo Jima and Okinawa in 1945, Avengers provided close air support for American ground forces, while also attacking Japanese naval units attempting to interfere with the invasions. The final months of the war saw TBF Avengers participating in strikes against the Japanese home islands. Carrier task forces operated close to Japan's coast, launching continuous airstrikes against military and industrial targets. Avengers bombed airfields, attacked shipping in harbors, and struck coastal installations. Japanese defenders, by this point desperately short of aircraft, fuel, and experienced pilots, could mount only limited resistance. For Japanese naval officers watching their forces steadily eroded by American air power, the TBF Avenger represented the kind of technological and industrial advantage they had no answer for. It wasn't just that the Avenger was a better torpedo bomber than the Kate. It was that the Avenger represented an entire system: advanced weapons, sophisticated aircraft systems, extensive pilot training, efficient maintenance and logistics, and industrial capacity to produce thousands of high-quality aircraft. Japanese captured examples of TBF Avengers were examined when opportunities arose. Several aircraft were recovered from crash sites or forced landings in Japanese-controlled territory. These aircraft were transported to technical intelligence facilities for detailed study. The examinations followed patterns similar to Japanese analysis of other captured American aircraft. Measure everything. Disassemble major components, test materials, document manufacturing techniques. What Japanese engineers discovered reinforced conclusions they'd drawn from examining other American aircraft like the F-4U Corsair. The Avenger was built to standards Japanese industry struggled to match. Aluminum alloys showed consistent quality and proper heat treatment. Structural components were manufactured with precision and assembled with attention to detail. Systems integration was sophisticated, with electrical, hydraulic, and mechanical systems working together seamlessly. The Wright R2600 engine, when examined, revealed manufacturing capabilities that Japanese engine production could not duplicate. Cylinder machining showed surface finishes and dimensional tolerances measured in thousandths of an inch. Internal components like crankshafts, connecting rods, and camshafts demonstrated metallurgy and machining precision. The two-speed supercharger incorporated complex internal passages and precisely fitted rotating elements. Japanese attempts to develop comparable engines had largely failed to achieve similar performance and reliability. The Mitsubishi Kasei engine family, roughly comparable in displacement to the R2600, produced less power and required more frequent maintenance. Japanese engine manufacturers struggled with quality control as the war progressed and as strategic bombing disrupted production. The hydraulic systems in the Avenger used components manufactured to standards that ensured reliable operation. Pumps, actuators, valves, and lines were precisely manufactured and properly sealed. Japanese hydraulic systems, while functional, often suffered reliability issues due to less precise manufacturing and lower quality seals. The electrical system incorporated generators, voltage regulators, wiring, and switches that demonstrated mature electrical engineering. The turret drive motors operated smoothly with adequate power reserves. The instrument panel included sophisticated gauges manufactured with precision. Japanese electrical systems worked, but components were often less reliable and manufacturing quality was more variable. Perhaps most significantly, the overall build quality of the Avenger impressed Japanese engineers. The aircraft felt substantial and well made. Every component, from major structural elements to small fasteners, showed consistent manufacturing quality. This overall quality stood in sharp contrast to Japanese aircraft production by 1944 and 1945, where material shortages and production pressures were degrading quality. Japanese technical reports on the TBF Avenger acknowledged American technological and manufacturing superiority. The reports were professionally written and factually detailed, but the implications were clear. In torpedo bomber design, in aircraft systems integration, in manufacturing quality, and in industrial capacity, the United States held overwhelming advantages. Japan had no equivalent aircraft in production and lacked the industrial capacity to develop and manufacture a comparable design. The strategic implications extended beyond torpedo bombers. The TBF Avenger was one aircraft type among many, where American technology and production exceeded Japanese capabilities. American fighters, dive bombers, patrol aircraft, and transport aircraft all demonstrated similar patterns of superior performance, rugged construction, and sophisticated systems. American industrial capacity produced these aircraft in overwhelming numbers. In 1944 alone, American factories produced approximately 96,000 military aircraft. Japanese production in the same year totaled approximately 28,000 aircraft. This roughly 3-to-1 production advantage meant that even if Japanese and American aircraft were equivalent in capability, which they were not, Japan would still face overwhelming numerical disadvantages. The quality gap compounded the quantity gap. An American aircraft produced in 1944 was likely to be better built, more reliable, and more capable than its Japanese equivalent. American pilot training produced aviators with more flight hours and better preparation. American maintenance and logistics systems kept aircraft operational at higher rates. American doctrine evolved more rapidly, incorporating lessons learned and adapting to changing conditions. Japanese naval aviation recognized these realities by 1944, but lacked means to address them. Industrial capacity could not be conjured from nothing. Manufacturing quality could not be improved when raw materials were scarce and skilled workers were being drafted. Pilot training could not match American standards when fuel shortages limited flight hours and when experienced instructors were killed faster than they could be replaced. The TBF Avengers combat record reflected these systematic American advantages. Avengers flew tens of thousands of combat sorties during World War II. They sank dozens of Japanese warships, including carriers, battleships, cruisers, and destroyers. They destroyed hundreds of merchant vessels, disrupting Japanese logistics and strangling Japan's war economy. They provided close air support that enabled American ground forces to capture island after island across the Pacific. Loss rates, while not insignificant, were dramatically better than earlier American torpedo bombers. Where the TBD Devastator suffered catastrophic casualties at Midway and other early battles, the TBF Avenger achieved roughly 70% survival rates, even in heavily defended environments. This survivability reflected the aircraft's speed, ruggedness, and defensive armament, but also reflected improving American tactics and overwhelming fighter escort that protected strike aircraft. For Japanese forces facing these attacks, the experience was increasingly hopeless. Defending against slow, predictable torpedo bombers with light armament was one thing. Defending against fast, rugged aircraft carrying advanced weapons and operating with strong fighter protection was entirely different. As American forces advanced across the Pacific, Japanese defenders found themselves facing strike packages where everything – aircraft quality, pilot training, weapons effectiveness, tactical coordination – favored the attackers. The story of the TBF Avenger and Japanese efforts to understand it exemplifies the broader narrative of the Pacific War's technological dimension. Japan entered the war with capable aircraft and experienced crews. Early victories at Pearl Harbor, the Philippines, and throughout Southeast Asia suggested Japanese aviation could compete effectively with Western powers. But those early victories masked underlying weaknesses. Japanese industrial capacity was a fraction of American capacity. Japanese aircraft designs, while effective in 1941, were difficult to improve significantly because manufacturing limitations prevented incorporation of more powerful engines, heavier armament, or sophisticated systems. Japanese pilot training, while producing skilled aviators initially, could not sustain quality as losses mounted and training resources diminished. American industrial might, technological innovation, and systematic approach to warfare created compounding advantages. Better aircraft, better weapons, better training, better logistics, better doctrine, each advantage reinforced others. By 1944, the technological and numerical gaps had widened to the point where Japanese forces could only delay defeat, not prevent it. The TBF Avenger epitomized this American approach. Take a clear-eyed assessment of requirements. Design an aircraft that meets those requirements without compromise. Engineer sophisticated systems that work reliably. Manufacture with quality control and precision. Produce in overwhelming numbers. Train crews extensively. Deploy with effective doctrine. Support with robust logistics. The result was an aircraft that fundamentally outclassed its opponents. Japanese examination of captured Avengers revealed all of this. The technical reports documented the aircraft's capabilities. The analysis acknowledged American superiority, but documentation and acknowledgement could not change underlying realities. Japan lacked the resources, industrial capacity, and time to develop equivalents. The last Japanese carrier aviation operations occurred in October 1944 during the Battle of Leyte Gulf. Remaining Japanese carriers, desperately short of aircraft and pilots, served primarily as decoys to draw American forces away from Japanese surface fleets. The strategy failed. American carrier aircraft, including hundreds of TBF Avengers, destroyed Japanese carriers and surface ships in a series of devastating strikes. After Leyte Gulf, Japanese naval aviation effectively ceased to exist as an organized force. Remaining aircraft and pilots were husbanded for kamikaze operations, deliberate suicide attacks that represented final admission that conventional tactics could no longer achieve meaningful results against American forces. The TBF Avenger continued its combat career beyond World War II. During the Korean War from 1950 to 1953, Avengers flew from carriers conducting strikes against North Korean and Chinese forces. The aircraft's range, payload capacity, and ruggedness made it valuable for close air support and interdiction missions even in the jet age. Many Avengers were converted for specialized roles after World War II. Anti-submarine warfare variants with sophisticated radar and sensors served throughout the 1950s. Airborne early warning versions with large radar antennas in ventral radomes provided fleet air defense coordination. Carrier onboard delivery variants transported personnel and cargo to ships at sea. Some aircraft served into the 1960s in various utility roles. Foreign air forces operated Avengers in some cases into the 1970s. The aircraft's robust construction and reliable systems made it suitable for extended service lives with proper maintenance. The final military retirement of TBF Avengers occurred in the 1970s, more than 30 years after the type's introduction, a testament to the soundness of the original design. For Japan, the encounter with the TBF Avenger was part of a broader reckoning with technological and industrial reality. Japanese engineers who examined captured Avengers understood what they were seeing: evidence of engineering excellence, manufacturing sophistication, and industrial capacity that Japanese aviation had been unable to match throughout the war. The lessons came too late to change the war's outcome. But they influenced post-war Japanese industry. The emphasis on quality manufacturing, continuous improvement, and systematic approaches to production that characterizes modern Japanese industry has roots partly in the hard lessons learned when Japanese engineers examined what American industry could produce during World War II. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe. The TBF Avenger represented more than an effective torpedo bomber. It symbolized a nation's ability to identify requirements, marshal resources, apply engineering expertise, and produce sophisticated machines in overwhelming quantities. When Japanese naval officers watched these aircraft attack their ships, they were witnessing not just tactical defeat, but strategic inevitability. The Americans had built an aircraft their opponents couldn't match, and had built it by the thousands. That combination of quality and quantity, technology and production, made American victory not just possible but certain. The examination of captured Avengers by Japanese technical personnel stands as acknowledgement of this reality, documented in reports that serve as silent testimony to the moment when one nation's engineers confronted another nation's capabilities and understood the full magnitude of the challenge they had faced. Japanese aviation would recover in the post-war era, but never again would Japanese engineers underestimate what American industry could achieve when given clear objectives, adequate resources, and the freedom to innovate without constraint. The TBF Avenger's legacy extends far beyond its wartime service. Nearly 80 years after its combat debut at Midway, restored Avengers still fly at air shows, their distinctive engine roar and robust silhouette reminding audiences of a time when American industrial might turned the tide of global conflict. Museum examples stand as three-dimensional history lessons, allowing visitors to appreciate the engineering sophistication that Japanese analysts documented in their sobering technical reports. For the engineers at Yokosuka and Tachikawa, who examined captured Avengers in 1944 and 1945, these aircraft represented an uncomfortable truth, that courage and skill alone could not overcome systematic advantages in technology, manufacturing, and resources. Their meticulous documentation of American capabilities served not as intelligence for future victories, but as admission that the war they were fighting had already been decided by factories in Bethpage, Baltimore, and countless other American industrial centers. The story of Japan's encounter with the TBF Avenger reminds us that wars are won not just on battlefields, but in design offices, on factory floors, and through the accumulated advantages of nations that can turn engineering vision into operational reality at scale. If you enjoyed this deep dive into World War II aviation history, please subscribe to our channel for more detailed historical analysis. Share your thoughts in the comments below, and check out our other videos exploring the technology and human stories that shaped the Pacific War.